Hi, I'm Chris, and in this video we're taking a look at question 19 from this year's PSAT Math, Section 2, and it gives us the absolute value of a minus b is equal to 5, the absolute value of a minus c is equal to 3, and the question is asking us to solve for the absolute value of b minus c, and we have Roman numeral options. Roman numeral 1 is 2, Roman numeral 2 is 4, and Roman numeral 3 is 8. So the key with absolute value questions is to understand that when you're looking at the absolute value equations, you have the option of setting it equal to both the positive and negative result. So here, for this first equation, we have a minus b could be equal to 5, or a minus b could be equal to negative 5. And the same is going to be true for each of our absolute value equations. You could have a minus c equals 3, or you could have a minus c equals negative 3. And when we solve each one of those, if you were to solve and then go to plug into one of the other equations, you can test out different values and you can see if it's possible for b and c to be 2 units apart, 4 units apart, or 8 units apart. So let's try that out with some numbers here. And whenever you have a lot of variables, picking numbers is a great strategy to use. So for a minus b to equal 5, let's pick two numbers that are 5 units apart. For our example here, we'll try something like maybe 7 and 2. See how that works. Okay, so if a is 7 and b is 2, let's see how the rest of these problems would play out with that set of numbers. If we pick a is 7, for this equation where you have a minus c equals 3, then that would mean c would have to equal 4 in order for that to be true. So for our first set of values here, we're going to have a is 7, b is 2, and c is 4. So if we try that over here, if we have a is 7, b is 2, and c is 4, when we look for b minus c, 2 minus 4 would be negative 2, and the absolute value of negative 2 is 2, which lets us know that Roman numeral 1 is a possibility. So, as is the case with any Roman numeral question, as soon as you make a decision about one of the Roman numerals, you want to go ahead and eliminate answer choices accordingly. So we know that the correct answer choice has to have Roman numeral 1 in it, which means we can eliminate all other choices that do not contain Roman numeral 1. So that's our first set of values that worked for that. Let's see if we can come up with another set of values that will work for these equations. So for a minus b to equal 5, we picked 7 and 2 and we tested it out and we got Roman numeral 1 checked off. So let's try a different equation to see if we can change it up a bit to potentially get one of these other values. So if we try a minus b equals negative 5, let's say maybe a is 1 and b is 6. 1 minus 6 would equal negative 5. So if we use 1 for a, here to end up with 3, that would mean that c would have to equal a negative 2 in this one. And if you have b equals 6 and c equals negative 2, let's see how this equation over here would work with those values. So now we're trying a different set of values for b and c. And when you plug it in, we get 6 minus a negative 2, which is the same as saying 6 plus 2, and that would give us 8. The absolute value of 8 is 8. Okay, so we know Roman numeral 3 does work, and we can eliminate any choices that do not contain Roman numerals 1 and 3. Now for Roman numeral 2, for b and c to be 4 units apart, let's see if that's possible, just to prove that we did everything correctly and see whether or not that one works. So I'm going to erase everything we have so far for Roman numerals 1 and 2. Now here, if we try any of these combinations, and sometimes, really to drive home the point, I'm going to show it on a number line. So here, if a and b are 5 units apart, we don't know which way they're located. So it could be an a here, and b could be 5 units this way, or b could be 5 units this way in order to get a positive or a negative 5. And then for a and c to be 3 units apart, that means c could either be 3 units this way, or c could be 3 units this way. So those distances are accurate, and no matter what you do, if you look at B and C, let me label these as 2 for those distances. If you look at B and C, we can see here what we got originally. B and C can be 2 units apart, which allowed us to check off Roman numeral 1. B and C can be a total of 8 units apart, which is what allowed us to check off Roman numeral 3. But no matter which way you shake it, B and C will never be positioned where they're 4 units apart. And so if you need to prove that Roman numeral 2 doesn't work, you can try it out here. But as is the case with most Roman numeral questions, if you're able to make a correct decision about some of the Roman numerals, then you'll oftentimes be able to come up with the correct answer choice just by process of elimination. And here we get Roman numeral 1 and Roman numeral 3 as the correct answer, which is answer choice E for question 19. For more, please feel free to check out question 20, and thanks for watching.